Namaste and welcome to Apna Gurukul Maths. And today we are starting a very new chapter, that is Lines and Angles, chapter number 6, NCERT class 9. Now, before I start this chapter, there's a very big announcement over here which I'm going to make. Now, I have decided now. First, we started only with the theory parts of all the chapters. Now, I thought that I will be I'll be discussing all the exercises of the NCERT class 9th book. And then the next thing which I'll be discussing with you will be the NCERT exemplar problems. Now, exemplar problems are the extra problem given by NCERT. Uh, the topics are the same, but the problems are literally a little bit higher order. And then I'll be doing almost a 3 to 4 hour session of only problem solving once a week, where I'll be covering mostly 100 to 200 questions regarding few of the chapters, whatever we have discussed in that particular week. So that is going to be perfectly all right for your preparations for creating your base very firm and strong when it comes to mathematics, class 9. And as we progress further as well. So let's get into the video. Let's understand lines and angles, chapter number 6, class 9, NCERT. So what we are going to deal in this chapter is now we have already understood what are lines, what are angles. Now, something we are going to study right now is properties of angles formed when two lines intersect each other. What happens when will be discussing about vertically opposite angles. We will be also discussing about linear pair, because linear pair is nothing but we'll discuss that, a line and a ray falling on that. And then properties of angles formed when line intersects. When a line intersects two or more parallel lines, when we have two or more parallel lines and there is a line intersecting all of those, what happens to the properties of angles? These will be the major focus of this particular chapter. Now, why do we need to study this chapter? Why do we need to study the lines and angles chapter? Now, let's beautifully understand this. Now, as I have already told you, whatever we are studying right now, you might not be seeing all of its applications right in front of you, but yes, these are creating a base for you to use it in the future. For example, if you go to like architecture or architectural engineering, over there you cannot get away with that particular kind of course without the good knowledge of lines and angles. And this chapter is a basic preparation for you for a bigger vision of your life. You might not use it if you're not interested in architectural engineering. Then why do you need to study this? Then obviously in physics you have a few concepts if you need to understand, like ray diagrams, laws of refraction, laws of reflection. Over there, to understand those laws perfectly, we need a good understanding of lines and angles. Now, for sea travelers, suppose you become a very good traveler over there. If you travel the sea, if you travel through aeroplanes, if you travel through road, even road, lines and angles becomes a very effective tools. Okay, so that's why we need to understand these properties of lines and angles in theoretical knowledge. So let's begin with the chapter. So we will start this chapter with basic terms and definitions, which you have been already knowing, but let's quickly revise it. So what is a line segment? A line segment is a line with endpoints. Over here, as you can see, there are endpoints. So this becomes a line segment, right? Now, what is a ray? A ray is a line segment, is a line which has on one side it has endpoint, and on the other side it keeps going on and on and on. For example, as you can see the figure, towards the right side it keeps going on and on and on, and over here it is fixed point. It is not moving anywhere. When it comes to a line, it is extended to both the ends without stopping anywhere. They will keep extending towards infinity. Yes. Now we represent these dots to represent the endpoints, and these arrow represents that the line keeps on going on and on and on. That's why a line is represented by the arrow on both sides. A ray is represented by an arrow on one side and dot on the other side. A line segment is represented by dot on both the sides. I hope this basic thing is very much clear. Now comes something called as collinear points. So collinear points are points that lie on the same line. For example, I draw a line over here. This is the line. no matter how many dots I dot. See, all of these dots are on the same line, right? They are called as collinear points. Now, if I draw some dots over here or some points outside this line, now they are called as non-collinear points, and that is what is the next definition. Now, the fifth one is angle is formed when two rays originate from the same point. Now, over here, suppose we have one point and there are two rays originating from this one point. Now, once they originate from these 2 points, they form something called as angles. Okay. Now, these angles have different varieties. All obviously we have studied different types of angles. Acute angles, the angles which are less than 90 degree or greater than 0. Obviously all the angles are greater than 0. Then a right angle, which is 90 degrees. Then we have obtuse angle between 90 to 180 degrees, that's straight angle. And then we have reflex angle, which is 180 degree to 360 degree angles. I hope that is very, very much clear for you. Now then, something called as arms of an angles. Now the rays which makes an angles, they are called as arms. So these are arms, and this is also an arm. Okay, although they are also called as rays, but once they have formed an angle, they are now called as arms of an angle. These are little basic definitions. Now, what is the vertex of an angle? So that point where the two rays originate from to make the angle. So this point is called as vertex. Yes, very good. Now we have something called as complementary angles. So complementary angles. Now, complementary angles are a pair of angles which, when you add it, they add up to 90 degrees. So they are called as complementary angles. Then we have something called as supplementary angles. I'm very much sure you are very clear with this. So they are a pair of angles which sum up to 180 degrees. Then the next definitions comes out to be adjacent angles. Now, this is one definition which I want you to listen very, very carefully and pay very close attention on this. Now, for an adjacent angles, you need to have three important points. First, it should have a common vertex. Second, it should have a common arm. And third, the non-common arms around different sides. They should be around the different sides of the common arm on the opposite sides. What do I mean by that? Let's quickly understand with this with a figure. Now, let's suppose this is O is the vertex A, B, C. Now, my question is, can we say that angle AOC and angle AOB, can we say that they are adjacent angles? Now, if we only go with the definition that it has a common vertex and common arm, let's see what happens. Now, angle AOC and AOB both have this vertex common, and AOC is this particular angle. AOC is this angle and AOB is this angle. That means AO is the common arm. Yes, AO is common arm over here. Now, my dear friends, try to understand very, very carefully. Okay. Now, AO is the common arm, but you can see over here that both the arms which are not common, they are on the same side of the common arm. This is where the third criteria of adjacent angles comes into play, that both the non-common arm should be on the either side of the common arm or on the opposite side. Let's try to understand. Now, let's suppose I'm talking about angle AOB and angle BOC. When we talk about this, angle BO is the side BO is the common arm. Yes, ray BO, I'm sorry, is the common arm. And as you can observe, AO is on the left side while OC is on the right side of this particular ray. And that makes it angle AOB and BOC as adjacent angles, while the other case is not an adjacent angles. They are just angles. They are not adjacent angles. I hope this makes sense. You will be remembering this particular definition. Then comes the linear pair. Now, what happens in linear pair? Suppose this adjacent pairs, now adjacent angles are in such a way that they form a 90-degree, so they form a 180-degree, then that is called as linear pair. We will be discussing about this in a little more detail after a while, which is called as linear pair axiom. Then we have some basic terms and definitions called as vertically opposite angles. Now, what do I mean by vertically opposite angles? Suppose two lines are two line segments or two rays, anything is perfectly all right. Over here, I have taken line segment. Two line segment when they intersect, and that is when they are called as intersecting lines. When they intersect, as you can see, they have an opposite angle. What is the meaning of opposite angle? As you can see very clearly, one above the means they are lying on the opposite side of each other. So these opposite angles are equal. So these are basically basic that is actually a theorem which we'll be studying again after some time. But let's for now understand what are vertically opposite angle. When two lines intersect or line segment intersect, the angles which are formed opposite to each other, they are vertically opposite angle. As you can see, 1 and 2 are vertically opposite angle, 3 and 4 are also vertically opposite angles. Then we have something called as non-intersecting line. Non-intersecting lines are the lines, or we can also have non-intersecting, sometimes we can say line segments, but let's discuss only the lines. So non-intersecting lines are the lines which when you extend to whatever extent you want, it will never intersect. So they are called as non-intersecting line. There's one more feature of this non-intersecting line, that if you find the distance between them, that remains always constant. Okay. If you want to verify, let's quickly verify it with the scale what we have right now quickly. And we have the scale. Let's quickly take the scale, and as you can see, this is around 3 centimeter. As you move forward on this on these two lines, this distance is always remaining constant, and no matter how big great extension you take for this lines, it will never change their distance, and these lines will never meet. That is why they are called as non-intersecting lines. Now let's quickly try to understand what a linear pair axiom. Now we have already understood about axioms and postulates and theorems in the previous chapter. Why are they called? What are they called? Now linear pair axiom, as you already know, that axioms are the statements which need not have a proof. They are accepted as it is in the world of mathematics. So axiom 6.1 says, if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degrees. Axiom 6.2 says, if the sum of two adjacent angles is 180 degrees, then the common arms of the angles form a line. Non-common arm, I'm sorry. Now, my dear students, pause the video, read both the axioms once again, and try to come back to me and try then answer my question, that why, or rather I would ask, what is the similarity between these two axioms? I hope you got the answer. Now, as you can see over here, the conditions are exactly the same, but I will try to make you understand in a little different way. Axiom 6.1 says, if condition A is true, then B is also true. And the second condition says, if B is true, then A is also true. Yes or no? Over here it states, if a ray stands on line. Over here the given condition is there is a line and a ray stands on that. I will show you the figure, then you'll understand it better. Now AOB is the line already, and OC is the ray which is standing on this. Then it says that then the sum of two adjacent angles so formed is 180 degrees. Now, over here, the result is the angles formed. If this angle is 160 degrees, then this angle must be 120 degrees. That is what this particular axiom 6.1 says. Now, try to understand what does axiom 6.2 says. It's just the opposite of that. It's just the opposite of that. and they are called as converse of the axiom or converse of the theorem. Sometimes we have converse of theorem, converse of statement is rather better, converse of the statement. Now let's try to understand what does it say. If the sum of two adjacent angles is 180 degrees, now try to understand, my dear friend. Over here, the angles are given. Quickly understand. Over here, the angles are given, as you can see, 50 and 130 degrees. These two angles, they are adjacent angles. Now, if these two angles sum up to 180 degrees, then the non-common arms PO and OQ, they will form a straight line. That is what is the second axiom says. I hope both the axioms are clear. Both the axioms mean the same, but they are converse of each other. Okay, now it's been introduced as a converse of each other because it is important for you to understand that sometimes the converse are true and the other times converse need not be true for a particular statement in mathematics. For now, in this linear pair axiom, the converse of the axiom is also true, and that's why it's been taken as an axiom. If it's not true, we do not take it as a valid statement. Okay, let's now move on to theorem 6.1. It says if two lines intersect each other, then the vertically opposite angles are equals. When we were discussing the basic terms, I told you, right, we have something called as vertically opposite angles. Yes. Now over here the theorem comes that vertically opposite angles are always equal. Let's begin the discussion. Let's try to prove it. Now my dear friend, as we have already discussed in Euclid's geometry, that axioms are the statement which need not have a proof, but theorems are the statement which we prove it with the help of axioms and postulates. Now we will try to prove this theorem with the help of the axioms we just now studied. What was the axioms we studied? Yes, you are absolutely correct. We studied about linear pair axioms, and we will try to understand this theorem with the help of linear pair axiom. Let's begin. Now, if two lines intersect each other, then their vertically opposite angles are equal. Here comes the figure. As you can see, now we have a line AB and line CD. They are intersecting at the point O, and here they form angle 1, angle 2, angle 3, angle 4. Now, 1, 2, 3, 4 are not the measure of the angle. They are the name of the angles here. Okay, now, please don't get confused with that. Now, here we have the figure. Now, let's try to understand how do we prove it. As I told, we will be trying to use the axiom what we have discussed, right? So as you can see over here, AB is a straight line and OD acts as a ray. So angle 1 and 2 are forming a linear pair. Similarly, if you see CD is a line, OB is a ray, and angle 2 and angle 3 are forming a linear pair. Similarly, there are 4 different linear pairs in this particular diagram. Let's use 2 of them to prove the vertically opposite angles are equal. Now we'll try to prove that angle 1 equals angle 3 because we have already seen in the definition of vertically opposite angles that 1 and 3 are our vertically opposite angles. 2 and 4 over here, according to this figure, are vertically opposite angles. So since AB and CD are straight lines intersecting at O, therefore, according to the linear pair axiom, angle 1 plus angle 2 equals 180 degrees and angle 2 plus angle 3 is also 180 degrees. What is the reason? Because CD is a straight line, OB is a ray, and as you can see, angle 3 and 2 are adjacent angles. I hope that makes a lot of sense. Now, once we have these two equations, we need to just play around with these equations and we will be able to find angle 1 equals to angle 3. That is what is our objective, right? Angle 1 equals angle 3. We have to prove it. Let's begin. So what do we do is, as you can see in both the equation, angle 2 is common. So why not take help of one of the equations and substitute the value of angle 2? That is how we do the substitution process. Let's begin. So from equation 2, I will find the value of angle 2. Angle 2, if I have to keep it there, angle 3 goes to the other side. It's positive here. So when it goes to the other side, it becomes a negative. 180 minus angle 3. Now substituting equation 3 in equation 1. So instead of angle 2, we will substitute 180 minus angle 3. So that is what we do. Angle 1 plus 180 minus angle 3 equals 180 degrees. negative. That is what we have done, the substitution. Okay, now as you can see, I can move this 180 to the other side. It's positive, so it came out to be negative over here. And as you can see that angle 3 is a negative over here, so when it comes, it becomes a positive angle, right? And here the angle 180 minus 180, that becomes 0. That gives us angle 1 equals angle 3. Now by the definition of vertically opposite angle, we know that angle 1 equals angle 1 and angle 3 are vertically opposite angles. So since angle 1 and 3 are vertically opposite angle, and from equation number 4 we have already shown that angle 1 equals angle 3, so hence the proof for the theorem, because that is what we started to prove, right? We were proving that vertically opposite angles are equal, and we have shown it here. So hence the proof. So that is one of the perfect ways to write the proof. If you want to take a note of this, quickly pause the video, take a note of this, and let's move forward. Now, coming on to example 1, we will try to solve one example based on vertically opposite angles. So in the figure which is given over here, lines PQ and RS intersect each other at point O. Now it says if angle POR and ROQ is equals to 5:7, that means we have the ratio. Then find all the angles. Let's try to understand how do we do that. We'll be using the theorem and the axiom so far. So for a easier solution, we will try to take angle POR as angle 1, because we don't want to write POR again and again. So we will assume it as angle aimed, which angle 1, we just change the name, okay? And angle ROQ as angle number 2. Now according to the question, since angle 1 is to angle 2, that is equals to 5:7, we can take therefore angle 1 equals 5x and angle 2 equals 7x. What is the x over here? Where x is the common factor of the ratio. Try to understand, my dear friend. When we write the ratio, we write it in simplest form. Whenever we try to write the simplest form, we eliminate some of the factors, right? So these factors, we don't know what is being eliminated from this particular ratio. That is why we assume it as x. Uses of algebraic expressions. I hope that makes sense. So where x is the common factor of the ratio. Now we have got the value of angle 1 and angle 2. Now as you can see over here, since POQ is a straight line, POQ is a straight line, and OR is a ray over that, that means angle 1 and angle 2 forms a linear pair. So angle 1 plus angle 2 equals 180 degrees. So angle 1 is 5x and angle 2 is 7x. So 5x plus 7x will give us 12x, which is equals to 180 degrees. So x becomes equals to 180 divided by 12, because 12 is in multiplication here. So when it comes to this side, it becomes a division. So 180 divided by 12 equals 15. Now, what will be the value of angle 1? Angle 1 is nothing but 5x, right? So 5 times x, the value of x is 15. So 5 times 15 is 75. Similarly, angle 2 equals 105. Now, the question is asking, we have to find all the angles. Now, we have found that the angle 1 equals 75 degrees. So angle 3 is also 75 degrees. That's very clear. If angle 2 is 105 degrees, angle 4 is also 105 degrees. And that is how we have calculated all the required angles according to this question. Now, there is two interesting questions which I want to ask you. Over here, as you can see, there are 3 line segments. Now, one is the line segment which is sitting horizontally, and 2 different line segments which are intersecting at the same point. Now, my question is, angle 1, 2, 3, are they forming a linear pair? I repeat, angle 1, 2, 3, are they forming a linear pair? My dear friend, it's absolutely true. They are forming a linear pair. Why? Because no matter how many angles are, how many adjacent angles are there, if it is forming a straight line, that will always sum up to 180 degrees, even if you make some more angles over here. I've made almost 1, 2, 3, 4, 5, 6. Even in this situation, it will form a 180-degree, it will form a linear pair. Rather, we'll not call it as linear pair. We will call it as angles which sum up to 180 degrees, because pair is a word which we generally use for only two angles. Okay, I hope that makes sense. Now, over here are angles 1 and 3. As you can see very clearly in the figure, 1 and 3. Can we tell that they are vertically opposite angle? Now, this is a very, very interesting question. Pause the video, think about it. Now, I hope you have thought about this and you got the answer. Angle 1 and 3, we cannot say this as vertically opposite angle. Why? Because vertically opposite angle, when we discussed, we had two straight lines intersecting at one position. In this situation, my dear friend, there are no two straight lines. There is only one straight line and two different lines. Can you see that? Can you see the difference between these two? Yes or no? Yes, if you can see the difference, that is why I told angle 1 and angle 3 cannot be said as vertically opposite angle in this figure. But over here, if I write it angle 1 and 3, then obviously it is vertically opposite angle, because they are only formed when we have two intersecting lines, not more than two intersecting lines. I hope that is very, very clear for you. So that is it for this particular introduction video of lines and angles. I hope that makes sense. We discussed theorem 6.1. In this chapter, there are almost 8 theorems, and then we will go jump into the problem solving part. I hope you loved the video. Thank you so much for your patience sharing. See you in the next video. Until then, keep smiling. Jai Hind. You were listening to Apna Gurukul Maths, one little step towards success.